Okay, last video for the chapter. This is on regression printouts. So in statistics, there are these printouts when they take X and Y variables and they put them in, kind of like we do in Desmos or the calculator, but there are these programs that are Minitab, SPSS, and we don't use those in our class. You can do stuff like that through Excel, but they will give a regression printout. What you need to know how to do is, how do I read this regression printout? So on my next test, you will see regression printouts. You'll see this on the AP exam. And right now, there's a lot of information on what we call a regression printout. Sometimes they have a graph. So like, for example, I have a graph over here. And if you look at the graph, remember the X variable. Oh, I have it on white for some reason. Anyway, let's get it on a different color. The X variable, of course, is on the X axis. The Y variable is here. So make sure you're reading those things, looking, what's my X variable? What's my Y variable? Then you will see something called the coefficients. All the rest of this stuff, there's a lot of stuff on here that we will do later. There's a t-score, a p-value. Sometimes that stuff is there, sometimes it's not. Right now in this chapter, there's two things you need to know. You need to know what are the coefficients. That's one, okay, and that's A or B. And then you need to know what are the variables. And the variables you have to read. So as far as the equation, you do have your formula sheet, but you should know that y hat equals A plus bx. Well, where do I get the coefficients? Where do I get A and B? Underneath the coefficients, they'll go in order. Here's A, here's B. Okay, there'll be two numbers there. It won't say A and B. It might say like 2. Oh, well then A is 2. And then it might say 3.7. Well, then B is 3.7. So it's going to say some numbers there. Then whatever's next to B, remember B is always next to X. Well, it's a little bit backwards on the regression printout, but whatever is here, that is the X variable. So if it says weight or height or something like that, that is the X variable. This is, however, not the Y variable, because the Y variable isn't next to A, so it goes A plus BX. It kind of goes right there. You have to look elsewhere. Somewhere it might say, oh, the dependent variable is study time or something like that. It'll say the Y variable. Or if it has a graph, it'll say the Y variable here. It'll also say the X variable here. But in that regression printout, you can get the right side of the equation, the A plus BX, from whatever the number is here, and then the X variable. Okay, so that's the start with a regression printout. Okay, there are some other things on there, but let's remember, A is the y-intercept, B is the slope. So you will just look under where it says coefficient. Here's A, here's B, that's the y-intercept, that's the slope. Then you might see r squared and r squared adjusted. We will never use r squared adjusted, never use it. Okay, we will use r squared. We've talked about that, the percent of the variation in y that is explained by x. So we're going to jump in. Can you look at this one and write the best fit line equation, otherwise known as the LSRL, or the least squares regression line? A lot of different names, best fit line, all those things mean the same thing. Can you look at this and can you simply write the equation? So pause the video as needed, but we are going to continue with the video. So here, all this stuff is junk. We don't need any of that in this chapter to write it. We also don't need r squared. So you could scribble that out and you can know, okay, all this is the stuff I need. Well, I've got A. A is negative 222 and B is 5.48. That's A, that's B. This height is X. So if I were writing it, I would go equals, now I don't know what Y is yet, we'll find it, equals negative 222 plus 5.488 times X, or times the height, and I would put that in there. So if I were writing it, let's see if I can manipulate this so I got the right side of the equation. There's the right side of the equation. Negative 222, that's A plus B times X. I didn't put in X, I put in the height. Let's write things in context. Well, where do I get the Y variable? Right here, it says the dependent variable is weight. So I put weight with the little hat on it, okay? And that's as simple as writing the equation. That should be something that if you see one of these problems, it's so easy, it's so simple to write. Okay, now it says predict the height, predict when the height is 70. Now, whether you're using the calculator, using the Inspire, let's grab a calculator here, equals, negative. Just wants to do that. So why does it want to do that? Negative. Why can't I get the other, no negative on there? I don't want the answer. Negative 222. I don't know why I couldn't get that off there. 0.48 plus 5 point something. 488 times, I think it was 70. Now, if you do it on Desmos, it's the same thing. Should get 161.68. Now, if I ask this question on the test, make sure you show your work. Make sure you give me your equation, write it down. Negative 222 plus 5.488 times 70 is 161.68. That would be the predicted weight. And probably in pounds here, we're going, we're in the US, we use pounds, so we're going to use that. Next question. Explain R squared. So, again, pause the video, practice R squared. If you can't do this on the test, you're going to be in trouble. You're going to miss a couple points on the test. Don't want that to happen. And you can go back to your notes where it says, what's R squared? It's the percent of the variation in Y explained by X. So our Y is weight, height is the X variable. So we look up R squared, and again, there's an R squared and an R squared adjusted. We don't use that, we use R squared. So 50% of the variation in weight is explained by length. Again, remember, use R squared, not R squared adjusted, 50.6%. Now we've got a question on a residual. We haven't done one like this yet, but it says a person that is 72 inches tall has a residual of negative 3.56. How much does he weigh? Now, sometimes a picture is worth 1,000 words, they say. Let's remember the best fit line is the equation. If you have a negative residual, that means that the point, the actual person's height is smaller than the line. But you can use this equation to do it. But I'll show you how we can do both of these. If the residual is negative 3.56, we would take that and we would, first, let's take the 72. Let's plug it into our equation. Now, if you are using an Inspire, if you go up and you highlight this, you can highlight this and you can hit enter. It'll copy it down. And then you can just simply replace the 2. So that's, if we substitute the 72 in the equation, we get 172.65. I'll embarrass myself and go to Desmos. I don't know that there's a way to do that. I suppose we can just highlight it. Control C, Control V. Control C is copy, Control V is paste. There might be another way to do that too. I feel like I discovered one, but I can't remember it. But we get 172.68. But Control C is copy, Control V is paste. The hotkeys, learned those back in 30-some years ago in college. Now, that is the prediction. Understand this equation, E is the residual. So if you put this in for E, and this in for Y hat, then you're looking for how much he actually weighs, which is Y. So E equals Y minus Y hat. If you substitute those in, negative 3.56 equals Y minus 172.5. If you add 172.65, add it to both sides, you get 169.09 pounds. Now, the other way to look at it is if you drew a line and you said, this is my prediction. My prediction is 172.65, And if I have a negative residual, if I subtract the 3.56, I subtract that, I'm going to get 169.09 pounds. So you have to know that equation on a test. It'll be on the reviews. It'll be on several of the practices. Make sure you know how to do that. Okay, so I want you to jump in. I want you to answer these different questions, some different questions on here. Why don't you go ahead and try this one, try the next one. I'll go over the last two, give you a moment. But again, you can pause the video. So how much time you need, that's really up to you as an individual. So here we go. Remember, if you're asked to do the least squares line equation, you don't need any of this stuff. You don't need r squared. You do need the coefficients. You've got a, you've got b, you've got x. So if we were going to write that side of the equation, we got equals 1212 plus 0.75 times the quiz average. We have to find the dependent variable or the y variable, and that's the final score. So we're going to put final hat. This equation is built to predict the final score on the test from a quiz score average that you did during the class. Next, it says explain the slope. We haven't done that in a little while. We did a lot of those. Here's an equation. Can you explain the slope? Suppose we could explain the y-intercept too. I don't have that on there. Just to review the y-intercept, if the quiz score average is 0, you would predict the final score to be 12.12. Okay, but let's do the slope. And again, hopefully you paused the video. Here we go. What is the slope? It's predicted the final score will rise 0.75. Remember, it's always y over x. Final score goes up 0.75 for 1 more % in the quiz average. It's always over 1, and the x goes up 1, and that's the x. Explain r squared. Okay, so again, we got to find r squared. R squared is 37. So 37% of the variation in final score, remember it's variation in y, is explained by x, average quiz score. Now we've got, I thought there was a residual question. Oh, there is. A person that averaged 80 on the quiz had a residual of -5. What was their final score? Okay, so first, take the equation that you made back here and plug in an 80. When you plug in the 80, you get 72.224. Now, E is the residual, -5, equals y minus y hat, 72.224. We look at what is y. If you add 72.24, you get 67.224. Again, the other way to look at it, if this is the prediction line, it's got a negative residual. Once you get the prediction, you would subtract. And that's all you're doing. You're subtracting 5 from that prediction, really. It's the same thing. All right, try the last ones. Pause the videos. Last ones will do for the videos on the chapter. All right, LSRL equation. Now this one has something tricky that we haven't had before. It's the starting salary in thousands of dollars. That is going to play into several of the answers. So salary in thousands, hat, the predicted salary in thousands, equals A, 14.816 plus 5.7066 times the GPA of the person. Explain the slope. We predict 5.7 more thousands of dollars. Okay, so this is 5.7 more thousands, or you can take 5.7 times 1,000 and you can get $5,706.60 more in starting salary for every 1 more grade point that a person averages. Okay, so that's where it's a little bit tricky, because when you define the slope or define the answer, you have to remember that these things are being predicted in thousands of dollars. So you either need to say it's 5.7 thousands, or you need to multiply it and you need to get $5,706. All right, next, predict the starting salary with a GPA of 2. So again, pause the video if I'm going too fast, but I do just want you to always know that that's the case. If you plug in a 2, you would take this and you substitute in a 2, and when you substitute a 2, you get 26.22. Well, that's a starting salary of $26,220 because you multiply that by thousands. If you say this, you need to say thousands of dollars. Okay, so don't forget that it's in thousands, so it's not $26 or not $26 an hour, it's 26,000. It's a little dated in terms of starting salaries. Okay, person had a GPA of 2.8 with a starting salary of 28,000. What is the residual? Now, this is going to be different than the other ones we've done. This time they're giving us Y. This is their actual, and you can substitute this in and get Y hat. So again, pause the video, but otherwise I'm going to move ahead. First, I would take the 2.8, substitute it in. We substitute it in, we get 30.79. Now that's $30,790. And you either are going to take the actual salary, 28,000, subtract 30.79, which is the prediction, and say they have a residual of negative 2.79 thousand or $2,790 less. If you leave these in thousands or turn this one into thousands and you take 28,000 minus 30,790, you're going to get that negative $2,790. So whether you get a negative 2.79 and say the word thousands, or you do it in thousands, that's the way we would do it. That ends the videos for the chapter. Thanks for watching. Hopefully you're understanding this stuff. We do have several reviews in this round, so do your best.